Hi everybody, Dr. Manny here. Welcome to Dr. Manny's YouTube Learn Shops. This is the basics in relation to statistics, and it's just an introduction. But there are numerous other parts if you want to follow through.
Okay, the learning objectives for this session are to justify statistics and their relevance in the research process, to recognise context where statistics can mislead, and to discuss the role of statistics in healthcare. And remember, this is just a basic. The whole program is just basics. Any more information that you want, you can discover that yourself with extended learning. Go to some of the YouTube lectures, which are really quite fantastic. Okay, basic terms that you need to be familiar with are census. And census is just the collection of data from a member of the population. And the aim of a census is to count the entire population of a country and at the location where each person usually lives. The census asks questions of people in their homes and group living situations, which includes how many people live or stay in each home and the sex, age and race of each person. That's census. So for example, have a look. What time do you leave for work? How many bathrooms do you have? How much money do you make? Okay, another term that you need to be familiar with is population. And in statistics, a population is a term that refers to a pool of individuals from which a statistical sample is drawn for a study. Therefore, any selection of individuals grouped together by a common feature can be said to be a population. For example, the nursing profession, the medical profession. The complete collection of all elements such as scores, people, measurements to be studied. The collection is complete in the sense that it includes all fields to be studied. For example, registered nurses in Melbourne, Australia, or all the nurses or members of the Critical Care Association in Texas in the USA. A population. From that we extract a sample to represent that population. On the humorous side, we have no population growth. Studying a population of the world would be almost impossible. No, it would be impossible because you're talking about 7+ billion people. So we use a sample. Now a sample is just part of a population. It's a small collection or a sub-collection of elements drawn from a specific population. For example, if your population was every Malaysian and you wanted to find out how much the average person earned, that's an example. Time and finances, however, as you, the researcher, stop you from knocking on every door in Malaysia. So you choose to ask 1,000 random people. This is 1,000 people, for example, in your sample. A random sample can be one choice. Another basic term is data. And data is the collection of facts, such as numbers, words, measurements, observations, or just descriptions of things. And observations, such as measurements, sexual category, survey responses that have been collected. In statistics, data are the individual pieces of factual information recorded, and it's used for the purpose of analysis, the process of analysis. The two processes for data collection are interpretation and presentation. And statistics is essentially the result of data analysis. Statistics, result of data analysis. So then, what are statistics? Statistics can be defined in a number of ways. So for example, statistics is just a discipline that concerns itself with the collection, organisation, analysis, interpretation and presentation of data. And when applying statistics to a scientific or a social model, scientific typically quantitative, social typically qualitative, it is the standard to begin with a statistical population or a statistical model. A statistic is just a number that represents an aspect of a sample, as we said. So for example, if we consider one hospital to be the sample of all hospitals, then the average number of patients in one hospital at the end of the month is an example of a statistic. Statistics can be applied in business, the physical sciences, environment, in the government, health and medicine, and many more. So what are some of the statistical practices? Statistics is used essentially in three main approaches, where we have factual information involving numbers, which is data, quantities, which have been derived from a sample data, for example, the mean or average of a data set. It can be in relation to an academic subject, which involves reasoning about statistical quantities, and it can be used correctly if you need to be able to think about statistics accurately. They have to be used correctly, otherwise they present the wrong information, as all research can do. So when we look at the research process, essentially it begins with asking the research question, then formulating the hypothesis, collecting the data, analysing the data, and evaluating the hypothesis, which all essentially creates a theory. But it's a cyclic process as well. Therefore, statistics can be utilised in each step of the research process, but it's primarily employed for data analysis. Let's review each step. Asking the research question. Asking the research question in relation to empirical research, we have to define that first. So empirical research is research that's based on observation and measurement of a phenomenon, directly experienced by you as the researcher. The data may be compared against a previous theory or hypothesis, but the results are still based on real-life experience. Research is based on information that can be verified by using our direct experience, but it cannot rely on reasoning, speculation, moral judgment, or subjective preferences as are in qualitative research. Empirical, for example, are women paid less than men for the same types of job? Non-empirical, does having blonde hair make a person more popular? Subjective, the second one, non-empirical. Scientific, the empirical example. So theory in research, what's a theory? A theory is essentially a set of assumptions and propositions used by all researchers to explain, predict, and understand social phenomena. It challenges or extends existing knowledge within the limits of the critical bounding assumptions. Researchers use theory to attempt to establish a link between observation and understanding why phenomena are related to each other in a particular way. So if we look at a theoretical framework then, a theoretical framework is the structure that supports a theory of a research study and consists of concepts together with their definitions and reference to relevant scholarly literature and existing theory. So the theoretical framework is essentially linked to previous research. And you can use it. You can cite it. You can modify it, as long as you acknowledge it. A theoretical framework introduces, describes, and summarizes the theory that explains, through a review of the previously tested knowledge of the variables, why the research problem under study is important and why it exists. In comparison, you've got a conceptual framework, which some academics believe is essentially the same as a theoretical framework. Yet there are other academics who believe that they are separate. Conceptual, possibly related to qualitative research, theoretical, related to quantitative research, but it's subjective. So I've included it here just for completeness. So a conceptual framework basically is the researcher's own model for illustrating variables that can specify the problem, and it gives direction to the study that you're undertaking. It may be unique, or it could be a previous model which has been modified by the researcher, by you, to conform to the topic of inquiry. But you acknowledge it. So for example, you could have hours of study, which is an independent variable, the exam score, which is the dependent variable which you want to investigate, and in between that you've got the moderator variable. So an independent variable isn't changed by other variables you're trying to measure. For example, the hours dedicated for study is an independent variable. How many hours does the student study? Then you've got the dependent variable, which is the one that you want to measure. I mean, it's a study here looking at how study hours impact on exam scores. So the dependent variable would be the exam scores, since that's what's being measured. Then in between, you've got the moderating variable. And it can be qualitative, non-numerical, values like race, socioeconomic class, or sex. Or it can be quantitative, numerical values like weight, height, or age. IQ is a quantitative variable that moderates the strength of the effect between study hours and exam scores. So what are the benefits of a theoretical framework? What does it do for you as the researcher? Well, it provides the basis for the hypothesis and the choice of your research methods. It allows questions of why and how to be addressed. It permits you to make generalizations about the phenomenon, and it helps identify the limits to those generalizations. It specifies variables, independent, dependent, that influence the phenomenon of interest. It highlights how the variables might differ and under what circumstances. When we look at the research hypothesis, which we'll be looking at in a little bit more detail as we go through this course, a research hypothesis is basically a statement predicting the relationship between two or more observable attributes subject to empirical verification. It basically explains what you expect to happen. You need to be clear and understandable. It has to be testable, measurable, and it has to have an independent and a dependent variable. It's the what, who, where, when, how, and why, essentially. So for example, a hypothesis is a statement that can be proved or disproved. For example, using the previous slides, a study designed to look at the relationship between the hours a student studies and their exam performance might have a hypothesis something like this. This study is designed to assess the hypothesis that students who study lengthy hours will perform better in an exam than students who do not study lengthy hours. And this is sometimes referred to as the alternative hypothesis, but we'll be looking at the null hypothesis and an alternative hypothesis later in this course. Types of hypothesis can be a simple hypothesis, a complex hypothesis, a null hypothesis, or an alternative hypothesis. A simple hypothesis essentially predicts the relationship between a single dependent variable and a single independent variable. A complex hypothesis, as it indicates, predicts a relationship of more, so two or more independent and dependent variables. The null hypothesis states a negative statement to support the researcher's findings that there is no relationship between two variables. And an alternative hypothesis states basically that there's a relationship between two variables of the study and that the results are significant to the research topic.
Let's look at statistical hypothesis. This is an examination of a portion of a population and uses statistical information from an area. For example, if you wanted to conduct a study on the Malaysian population, you would want to examine every single resident of Malaysia, a census. However, this is impractical. Therefore, you would conduct your research using a statistical hypothesis or a sample of the Malaysian population. For example, 50% of the Malaysian population lives beyond the age of 70. 25% of the population in Malaysia gets a divorce due to domestic violence. 45% of the population in Malaysia are Chinese. 75% of the population in Malaysia are well educated. Okay, let's look at our first review activity. Which of the following statements, from your perspective, would be an example of a simple hypothesis? 1. There is a significant change in health status when people drink only green tea compared to only soft drinks. 2. Overweight adults who value longevity and seek happiness are more likely than other adults to lose their excess weight and feel more sense of joy. There is no significant change in health status when people drink only green tea or only soft drinks. Drinking sugary drinks daily leads to obesity. So the simple hypothesis would be drinking sugary drinks daily leads to obesity. Review activity 2. Which of the following statements would be an example of a complex hypothesis? There is a significant change in health status when people drink only green tea compared to only soft drinks. Overweight adults who value longevity and seek happiness are more likely than other adults to lose their excess weight and feel a more regular sense of joy. There's no significant change in health status when people drink only green tea or only soft drinks. Drinking sugary drinks daily leads to obesity. Which one is the complex hypothesis? Number 2. Overweight adults who value longevity and seek happiness are more likely than other adults to lose their excess weight and feel a more regular sense of joy. Okay, review activity 3. Which of the following statements would be an example of a null hypothesis? There is a significant change in the health status when people drink only green tea compared to only soft drinks. Overweight adults who value longevity and seek happiness are more likely than other adults to lose their excess weight and feel a more regular sense of joy. There's no significant change in health status when people drink only green tea or only soft drinks. Drinking sugary drinks daily leads to obesity. The null hypothesis would be there's no significant change in health status when people drink only green tea or only soft drinks. The last activity, review activity 4, which of the following statements would be an example of an alternative hypothesis to the null hypothesis? There is a significant change in health status when people drink only green tea compared to only soft drinks. Overweight adults who value longevity and seek happiness are more likely than other adults to lose their excess weight and feel a more regular sense of joy. There's no significant change in health status when people drink only green tea compared to only soft drinks. Drinking sugary drinks daily leads to obesity. The alternative hypothesis to the null hypothesis would be there is a significant change in health status when people drink only green tea compared to only soft drinks. Now let's look at variables. Simply, a variable refers to a person, place, thing, or phenomenon that you're trying to measure in some way. You can think of variables in terms of cause and effect. The independent variable is a variable thought to be the cause, and the dependent variable is the effect. Cause, why it started raining. Effect, what I needed to do was get an umbrella. The cause is the independent variable. The effect is the dependent variable. So when we look at the types of variables, we mentioned the dependent variable is always the one that the researcher is trying to explain the objective of the research. The independent variable usually occurs earlier in time than the dependent variable. It's often seen as influencing directly or indirectly the dependent variable. In an experiment, you can manipulate the independent variable, for example, a diet, and measure the outcome of the dependent variable, a person's weight. Examples, the independent and dependent variables in a hypothesis. What is the effect of diet, the independent variable, on blood sugar levels, the dependent variable? The number of people living in a region, the independent variable, increases water consumption, the dependent variable. Students who study long hours, the independent variable, will have high grades in exams, the dependent variable. So let's review. Which of the following variables in this study would be the independent variable? The research hypothesis is students who study for long periods of time, hours, will have high grades in exams. They'll do well. The independent variable is study for long periods of time, hours. Which of the following variables in this study would be the dependent variable? The research hypothesis is students who study for long periods of time, hours, will have high grades in exams. The dependent variable will be is have high grades in exams. So when we look at statistics in research, scientific research, they're a crucial process behind how discoveries are made. And they make decisions based on data to make predictions. Statistical knowledge guides the use of correct methods to collect data, employ correct analysis, and effectively present the results. There are two main types of statistical methods, and they are descriptive, which summarize data from a sample using indices such as the mean or standard deviation, and inferential statistics, which obtain conclusions from data that are subject to random variations such as observational errors and sample variation. We want to solve problems and make decisions with scientific research, so we get data, understand the knowledge, make experiments to solve problems and make decisions. Why do you want to learn statistics? Well, you learn statistics to conduct research effectively and make decisions based on data collected from a project. To be able to read technical journals which contain some form of statistics in the results section, often complicated or appear complicated. To develop critical and analytic thinking skills and use formal, logical thinking abilities that are both high level and creative, and to be informed, as statistics can be used or misused. If you know the basic statistical concepts, you'll be able to be in a position better to evaluate information. And also, to have knowledge of statistics is to know when you have to access other resource people, such as a statistician. Statistics can also be misused. And this occurs when a statistical argument asserts a falsehood. It may be accidental or it may be purposeful. Depends on the agenda of the perpetrator. When the statistical reason involved is false or misapplied, this constitutes a statistical falsehood, a fallacy. And this includes a pattern of unsound statistical analysis, is related to data quality, statistical methods and interpretation, and are occasionally misused to persuade or influence or sell a product. It can also result from mistakes of analysis that result in poor decisions and failed strategies. So essentially there are three kinds of lies, according to Benjamin Disraeli. Lies, damned lies, and statistics. So in summary, there are 5 reasons to study statistics, and they are to effectively conduct research, to be able to read and evaluate journal articles, to further develop critical thinking and analytical skills, to be informed, to know when to resource someone with more knowledge than you in relation to statistics. So why study statistics in nursing? Well, believe it or not, you already do. Whether it's monitoring a patient's mean arterial blood pressure or recording the growth percentile of an infant, nurses use statistics in their practice more often than you realise. Using statistics and evidence-based practice helps nurses apply the most current research and evidence to patient care delivery. Nursing knowledge based on empirical research plays a fundamental role in the development of evidence-based practice for nurses, and examples of statistical techniques used in nursing research are the independent t-test, analysis of variance, and regression, which we'll be covering as we go through this course. So in conclusion, data is everywhere. Statistical techniques are used to make decisions that affect our lives. As a nurse and a healthcare professional, you will be making professional decisions that involve data. An understanding of statistical methods will help you make these decisions more effectively. Okay, that concludes this session in an introduction to the basics. There are 7 other parts to this basic statistics learn shop. And remember, it is just the basics. And you can get access to a lot of other information on some of the excellent YouTube videos. See you in the next session, and if you think this has been of any value to you, or any of the other Dr. Manny Learn shops, recommend them to your friends and colleagues. Thanks, see you soon.